This is my React application, connected to a Spring Boot backend. Here I display the login form. And this is the protected content returned by my backend. I can access the protected resources because I've used a JWT to authenticate my frontend. Today I will show both the frontend and the backend side of a JWT authentication. I will implement a complete full-stack application with React, Spring Boot 3 and Spring Security 6. It will be a login form with JWT authentication. This will be a long video where I will switch from the frontend to the backend application. This way, I will show how they interact and how to develop features developing both sides, the frontend and the backend. And before starting, please subscribe to my channel and let's go! What I'm going to do in the video, I will develop a stateless application. This means that the backend won't have any session and won't create any cookie. In a stateful application, the backend knows that the request comes from the same user and can fetch the user's history. In a stateless application, the backend knows nothing but what is sent at each request. If I want a state of the user, a history of the user, I must send it in the request. Here comes the JWT. The JWT is a token where I can store some information. Not too much and not critical information. I will store the user ID, maybe its first name and the last name, the roles and the expiration date of the token. I use the JWT to authenticate each request from the frontend to the backend. To use the JWT, I will send it in the HTTP header, in the authorization header. The authorization header have the following structure. I first say which kind of token, followed by the token itself. The JWT is a bearer token. I have some other tokens, as the basic or the digest. Okay, but who generates the token? The backend. And when? When the user logs in or registers. Once generated by backend, the frontend must store it. I will store it in the local storage and use it for each following request. Okay, so the backend must handle two kinds of requests, the authenticated request and the public request. In the security configuration, I must permit anyone to log in and register, and for the rest of the requests, they must be authenticated. And to ensure a request is authenticated, I will create a filter to read and parse the JWT before reaching the controller. Let's start by creating the Frontend project. I will now add some dependencies. Bootstrap to quickly organize and display pretty components. And class names to dynamically add classes to HTML elements. Okay, let's now create my first component to visualize. I will create a header and a welcome message. I must add the Bootstrap dependency here to be available in all my projects. And I remove the strict mode, which only displays warnings and errors about the code structure. This will be the main component. I will put all the CSS in this file. It won't be too much, as all will be handled by Bootstrap. Let's go now with the header component, just to show the title and the logo. Let's start the server and add some CSS. Now the app content component. At the moment it will only contain the welcome message component, but later I will add some logic to switch from the welcome message to the login form to the messages from the backend. And now the welcome component, just a big welcome message. Okay, I have the frontend project created. I will now create the backend project. Then the frontend will request a simple endpoint to display the results in another component. Let's use Spring Initializer to create the new Spring Boot project. Let's add some dependencies. Web as it is a web project, I need the endpoints. I will also add the security dependency, but I won't use it now. I want to store the new users in the database, so I need the Postgres driver and JPA. And Lombok for the code generation. I've unzipped the project and opened it with IntelliJ. Let's add some dependencies that are not available in Spring Initializer. Let's add now a controller to return some dummy data. Let's go back to the Frontend project. I will request the backend endpoint and display it in another component. For that, I need Axios. I will create a helper function and use it in the components I need. Let's create now the component to display the backend content. I name it Auth, as later it will protect the previous endpoint. So this will be the protected content, which needs authentication. Well, this is the first most common error when running a backend with a separated frontend. The CORS, the cross-origin resources sharing. This means that the backend doesn't trust the requests coming from the frontend. By default, the backend only accepts requests coming from itself. So I must configure my backend to accept requests from my frontend. I specify now all what's coming from the frontend. The frontend will send some credentials. I must accept them. The URL, of course. The headers. The HTTP methods. This is the time the options request is accepted, 30 minutes. This is applied for all the requests. I put this bin at the lowest position to be used before any Spring security filter. Now it works fine. Let's add some classes and CSS. Let's continue now with the logging. I start creating the logging in the frontend. The login component will be composed by two forms, the login form for known users and the register form for new users. I export the login and register behavior on the parent component. This way, the parent component can hide the login form once the user sends the credentials. With this method, I can store in the state the updated values of the fields. Let's go now with the HTML. I tried to use the pills from Bootstrap to switch the tabs, but I didn't succeed. If someone knows how to do it, write down a comment or create a merge request to my GitHub project. I will now adapt my app content component to display the login form, the welcome message, or the protected message. I will create two buttons. By default, the welcome message will be displayed. When clicking on the login button, the login form will be displayed, and once logged it, I display the protected message. I will also add a logout button to show again the welcome message. Let's finish by creating the buttons component. Let's go back to the Spring Boot application. I will add now the security configuration to protect all my endpoints. As said at the beginning, I will add one filter for the JWT requests. I start by adding an exception handler. This way I return a custom message when a security problem occurs. And I add the JWT filter before any authentication filter of Spring Security. I disable the CSRF to avoid complexity. If you want more details about this, check the video in the corner. I set to Spring that I am in a stateless application. This way, no session and cookie will be created by Spring. Those are the only endpoints where the authentication is not required. For the rest, I must be authenticated. Let's quickly create the exception handler. I return an unauthorized HTTP code. With this message. Let's start with the filter now. I extend once per request filter because I want this filter to be used only once per request. I check the authorization header. it must have the correct length and be a bearer token. If the credentials are valid, I add the authentication bin in the security context. If something goes wrong, clear the security context and throw the error. At the end of the filter, never forget to call the doFilter method. Adding the authentication bin to the security context allows me to add the authentication principal annotation as input parameter at any controller. This annotation will inject the authenticated user. So the filter will give to the controller an object of the authenticated user. I will create now the provider used before to return the authentication bin, but I will add a library to create and verify the JWT. To generate and read the JWT, I need a secret key. I can configure it in the application YAML file and inject it here, but I can also have a default value. To avoid having the secret key in plain text in the JVM, I encode it in base64. I want my JWT to be valid only 1 hour. To verify a JWT, I first decode it. If the validity date is exceeded, it will throw an exception. I will also check if the user exists in my database. Let's continue with the user's service. This service will handle the login and register. I use the password encoder to avoid having the passwords stored in plain text, but hashed password and unreadable. I also use here the password encoder to not store the passwords in plain text, but hash them. This is very important in an application when working with passwords. Let's take a look at the password encoder. Nothing complicated. I just choose the encoding algorithm for the passwords. I've also created a custom exception to be able to return the HTTP code I want, depending on the exception. For that, I will need an exception handler to return my custom message with the custom HTTP code. Let's create an aspect. This method will surround every controller, but will only be executed if an app exception is thrown. I've also created a map_struct mapper. Here I ignore the password field because it is not the same format. I will now configure the application to be connected with my database. I already have a database running on my machine. This initializes the schema of the database. By default, Spring Boot does it only for embedded databases. But for this case, for testing purpose, I want to initialize the database at each run. To create the database, I let Hibernate to do it based on the object definition. Spring Boot will automatically create the user table if it's not present. This is not a best practice, but for the current usage, it's okay. Instead, I should use a database migration tool, like Liquibase or Flyway. I've also created the user entity object, which is mapped with a table in the database. I don't name it user, as user is an existing table in Postgres. Let's go now with the authentication endpoints, the login endpoint and the register endpoint. Once logged, return a fresh JWT. Same for the registration. Return a freshly created JWT. When creating an entity, it is a best practice to return a 201 HTTP code with the URL where I can find the new entity. The backend is ready. There is one last step in the frontend. Once the user logs in, a JWT is returned to the frontend. I must now store the JWT and use it for the following request from the frontend. I will update the Axios helper to store and read the JWT from the local storage, and when available, use it in all the requests. Now, after the login or registration is done, I store the JWT. Let's now try a complete login. Here is my frontend. I will open the Inspect tools. This way I can see all the requests to the backend. I can show the login form or hide it and show the welcome message with these two buttons. I will first register my user. Here is the request to the backend, where I register my user with the payload and the response, where I can find the token. Followed by that, I have the messages request with the protected content. Now I will log out. And this time I will log in with the already existing user. Here is the login request, which is successful with the token, and the messages request, which returns me the protected content. In the header of the messages request, I can find the token in the authorization header. And that's all. I really hope you enjoyed the video. I hope I've been clear enough about how to develop a full stack feature, going from the backend to the frontend, testing all together. And if there are more features you want to see in a full stack point of view, leave a comment. I really encourage you to write down a comment about what you liked and what you want to see, because I've made this video based on your previous comments. As always, make sure you subscribe to my channel and click on the like button. Share the video on your network, and see you soon. Bye!